Today we'll study about the background processes. And yesterday we discussed two mode how to shut down databases today, and we'll discuss further two more processes. Let's start with background process, which is mandatory when you start a fresh database without any options enabled or without enabling any kind of features. Like there are much of the features available apart from the normal databases, and like the rack data guard available. So when you install a fresh database without enabling any kind of accidental features or any functions, what exactly background processes are there? There are a total 6 background processes which are mandatory. If any of these 6 processes is not up and running, that means your database is in trouble. It's down or something have happened to your database. So what are the background processes? To maximize the performance and accommodate many users, multi-process Oracle database systems uses background processes. Background processes are the process running behind the scene and are meant to perform certain maintenance activity or to deal with abnormal condition arising in the instance. So instance means the database. Each background process is meant for a specific purpose and its role is well defined. Background processes consolidate functions that would otherwise be handled by multiple databases programs running for each user process. Background processes synchronously perform I/O and monitor other Oracle database processes to provide increased parallelism for better performance and reliability. Background process is defined as any process that is listed in V $process and has no null value in the P name column. Not all background processes are mandatory. For instance, some are mandatory and some are optional. Mandatory background processes are DBWN, LGWR, CKPT, SMON, PMON, and RECO. All other processes are optional, will be invoked if particular feature is activated. Oracle background processes are visible as separate operating system process in Unix or Linux. In Windows, they run as a separate threads within the same service. Any issues related to background process should be monitored and analyzed from the trace log file generated and the alert log file. Background process started automatically when the instance is started. So these are the 6 mandatory background process. Now we'll understand the 6 background process. But before that, we'll understand what is the this is the actual SGA. So SG is a memory of database. So apart from the background process, there are many things Oracle does. Oracle database is responsible for storing files on the data files on the storage area in the form of tables, objects, indexes, functions, triggers, and in that form. Apart from that, it is also responsible for managing your request. It could be DML, DDL, data manipulations like updating the existing table, inserting new records, deleting the older record from the column. Also, it is responsible for giving the results. Like sometimes you can go for select query, you want to fire a query, select star from table where employee name will displace. So all these things are done under the SGA, name is System Global Area. The System Global is defined in such a way that all the requests, whether it's for update, if you're updating something, it will go to different part. If you're just selecting, putting a query for select star from the EMP, just a normal query, select query, it will go different part. Now, also at the same time, it have to maintain a consistency of the database. Example, now some user is updating a table and while performing update, the database got crash. So the database role is also to make the database in a consistent manner so that next time somebody query the table, it should show either the consistent data or it shouldn't show any kind of update to the table. Same time, it has to make a process that after, like if there's a huge number of records being updated, it have to mark, like after 1/4 of the record is updated, it is going to mark that this record has been updated to some of the file, so that at least, because the thing is that before and after, you might have another rollback. So when you update a table, before and after image copy of the data is captured in the database buffer cache or in the Oracle database, so that if somebody roll back the changes made to database, previous changes can be shown back and the new changes will be wiped out from database. So we will understand this one. Okay, then let's understand the first background process. What is DBWN? The name itself says ki database writer. It's a database writer. So maximum 20. So by default, one database writer comes with the fresh database, and you can configure depending on the size of your database and also number of transaction, number of IO your database performs. If your database is a company's database, it's a very huge, which perform huge number of transaction on a daily basis, have a huge number of IO. In that case, you would need more and more database writer. So you can configure, you can increase, you can decrease, but by default, at least one should be up and running. Whenever lock switch is occurring in reader lock, the file is becoming current or to active stage. Oracle calls DBWN and synchronizes all dirty blocks in database buffer cache to the respective data files, second or randomly. Database writers or dirty buffer writer process does multi-block writing to disk synchronously. Disk means the storage area where your data files are available or your database resides. Synchronously, one DBWN process is adequately for most systems. Multiple writers can be configured by initialing parameters db underscore writer underscore processes defined on the number of CPUs allocated to an instance. To have more than one DBWN only makes sense if each DBWN has been allocated its own list of blocks to write to disk. This is done through the initial parameters. DB underscore block underscore LRU underscore latches. If this parameter is not set correctly, multiple DB writers can end contending for the same block list. The possible multiple DBWN process in rack must be coordinated through the locking and global cache process to ensure efficient processing is accomplished. Now let's understand what is DBWN. Now, when a user performs any kind of task like update or insert, I would say insert, delete. Now, this is database buffer cache. It's a cache. So your request will be handled by database buffer cache. Now, database buffer have a memory. It have a huge number of, it have a records, like the way it depends on the size of a database buffer cache. Now, you have somebody have inserted delete and somebody have also used command like select star. Yesterday we have discussed select, that how the select query works. Now you have entered select star from EMP, and now you are the only one who have selected star from EMP. Now that data is put in a buffer cache. Now after specific time, nobody have used that query, so that memory will be removed. That memory will be, or data will be removed from database buffer cache. Now that will become as a dirty buffer. Also, when you insert or delete something, it goes to your database buffer and it have a specific size. Like this is my database buffer cache. Now it keep, like every time you perform any kind of actions, the memory gets allocated. It directly, when you perform any kind of actions, it doesn't go to your data files. This is my data files. Data files which have .dbf. When you perform any kind of action, this won't go directly to data files. First, it will go to the database buffer cache. Database buffer cache. It will update, or it will hold the query or data with itself, and after it gets full. Example, now there are huge number of update or different kind of commands coming on the database buffer. So it have to hold all the records. So it's like least record. Now it will filter out least record, which was the least action performed on the database. Now the least performed action will be called as a dirty buffer, and they will be removed and they'll be written back to data files. Now delete command which you have executed earlier, it have holded the data with itself. Now when have it reached its threshold or checkpoint got occurred. Checkpoint is something which marks the data files in the control log files and everywhere with the consistency of database. It checkpoint occurred, it will take the record which have changed and mark or put its records consistent or put the record to the data files. So all your actions which you have performed on the database won't go to data files immediately because it requires IO. Because performing any kind of action to your database data files, it requires IO, because in that case it have to spend more time, more CPU, more RAM will be required if it have to write anything to database files. Now data file buffer is invoked when we question like when it is invoked. When dirty block in SGA reaches threshold value. Threshold means it have some limitation. It might have some example. It have 1 GB of memory. So, and it is holding huge number of records like insert, delete, select, star. There are many things which is happening on the database sides. So after it gets full by 1 GB, automatically DBWN writer, DBWS writer, it will go and ask to remove the dirty buffer, which was least used, called LRU, least used will be flushed off from the database buffer cache and will be written back to your database files. So with the help of this process, it involves less IO with your database or data files, which brings your system quite more faster. SGA is something which is based on your memory. Memory means RAM. Data file is something a file resides on the storage area. So storage area might be locally available to your database, or it might be mounted with the help of NAS or SAN. It depends how it is mounted. Okay. Remember, DBWN is the only background process which is responsible for writing to database file. So DBW was the process which made this buffer cache to write data files. DBWN. So because this is the process which have made database buffer cache to write to the data files. Okay. Apart from this, we'll go now understand the portable. When the database is shutting down, normal transaction immediately with some dirty blocks in the SGA. Shutting down, like when suppose you're writing something, inserting, deleting something, okay, and suddenly somebody have executed shutdown immediate. In that case, it have to mark consistency of a database. So what it will do, it will go and to the database buffer cache and it will mark all dirty buffers to your database files. Now all the records which you have updated earlier, which it was holding with the database buffer cache, will be marked back to your data files or any other files. Now this will make the database consistent before database goes down for your down. DBWN has a timeout value 3 seconds by default, and it wakes up whether there are any dirty blocks or not. By default 3 seconds, and if there are dirty blocks are something which are least used. Least used means a record, somebody have you have deleted some kind of record, but apart from that nobody have else touched that table, that objects. You have selected a select from EMP, apart from you nobody have else done that. If there are number of record which has been used by huge number of people, that memory or that object will be put in a database buffer cache because it was mostly used. So it is most used, that means it has been put in a buffer cache. So next time the database doesn't have to go to database or data file files to pull the data. So in order for the performance purpose, your all the most frequently used or less used will be put in a database buffer cache. When a checkpoint is issued, when a server process cannot find a clean user buffer after scanning a threshold number of buffers. When a use table wants to enter into SGA and Oracle did not find in free space where it decides to flush out LRU, least used blocks, and which happens to be dirty blocks. Before flushing out the dirty blocks, Oracle calls DBWN. Oracle rank ping request made when table dropped or truncated. When table space going offline or read-only backup. So these are the checkpoints, or these are the process when the DBWR is invoked and all dirty buffers or anything which is already standing on the debugger will be called or will be flushed off. Flush off means it will remove the data from the buffer cache and it's going to mark its presence or going to make the changes to database files because it has been removed. That means it doesn't delete, it's wipe out means it moves from buffer cache and it put that data in a database files. Now that data is no more available in buffer cache, the data is directly available in database file. Example, now you have performed select star from EMP table. Now your data, which is a local, which is a temporary memory, which is a temporary select star from EMP, has been copied to database buffer cache. Now now that data has been copied, but after that somebody have performed select star from table, from department table. Now again that is available on this one. Now again somebody have done select star from account department. Now there are 3-1. Now one by one new request is coming and all the requests like staff EMP, they are not being used at all. In that case, they will be marked as a dirty buffer and they will be removed from the buffer cache. So next time if the same query comes, again the database go back to database file because that was used very frequently and it was used long time back. Log writer. This is the database buffer cache, log cache, library cache, and data cache. We will understand what are the other things. But let's understand this DBWR. Now log writer. Log writers redo data from redo log buffer to online redo log files each sequentially. Redo log file contains changes to any data file that the content of the redo file is file ID, block ID, and new content. LGWR will be invoked more often than DBWN as long as files are really small when compared to data files, KB with GB. Every small update we don't want to open hugely gigabyte data files, instead write to the log file. Redo log file has 3 stages: current, active, inactive, and is cyclic process. The newly created redo log files will be unused state. When the LGWR is writing to a particular redo log file, that file is set to be current state. If the file is filled up completely, then a log switch takes place and the LGWR starts writing to the second file. This is the reason every database requires minimum of 2 redo log groups. The file which is filled up now becomes the current. Now we'll understand what is LGWR. Now, this is my database. The database backup was taken at 12 p.m. And after that, the database ran perfectly fine till 2 p.m. Okay. Now, database ran perfectly fine till 2 p.m. Now, suddenly at 2 p.m., database got crashed. Now, how would I recover database till time, correctly, perfectly fine? Because backup was taken at 12 p.m. So I have no backups between 2 hours, that like between 12 p.m. and 2 p.m. And how would I take the recovery till time? How will I ensure that all my database transaction which have happened till 12 p.m. should be consistent? Because the backup which was taken was at 2 p.m. So what really happens? The redo log file. Redo log file is something which is responsible for keeping the last changes made to the database in redo groups. Okay, it will have record every changes made to your database to the reader log files. So what we'll do in that case, we will recover database till 12 p.m. and after that we will apply the reader logs. Restore last backup, then apply reader logs. So reader logs are something which records every changes made to your database in the form of reader logs. Reader logs. Now my database has files. Now database have parameter files. There are more database files which are called reader logs. Logs. Parameter files are SP file, E file, control. These are the files which database require before starting up. During the startup, these files are required. Database files are something which is required for storing your database objects on the storage area. The reason is that the target or the goal of Oracle database is to have less communication or less I/O with the file stored on the storage area, because that requires much of I/O and takes time. And database is something which is a fraction of seconds you should get your data. Database should be faster. So the reason is that like example, you are one user performing a transaction. Okay. Now you made some changes to the database, so like the committed transactions. So just because for you, if it have to go and write those changes to DB files, that might be there might be hundreds of users like you, and every time a hundreds of users ask to go and perform a committed and then write to a database file, that means it has to write data to DB file which is available on the storage side 1000 times per second, nanoseconds. That will be huge number of IO will be involved. So database will not have that much of memory to perform its other operations, because database is also working with the help of RAM and CPUs. So what it does, it consolidate all the transaction made changes in the form of reader logs. Okay. And reader log will have some size like 50 MB, 1 GB, 2 GB. When you might have made transactions. So your transaction example I'm giving you, like your changes which you have made to database might be for 1 KB or 2 KB or 1 MB. So in that way, unless it reaches reader log file size, it will not go and make any changes to database file directly. So the way Oracle database is designed, that every record which you make changes, it will record it somewhere. It's not going to wipe out. Even the database before database shuts down crashes, it will make sure that this record logs are available. So when next time whenever you start the database, it will read the files, the entries, the changes made to database file from the reader logs, because database file, it will check from the control file that this is the changes made. But what changes were made will be copied from, or will be copied or made an image copy from the reader logs file. The target of database is to have less IO with the storage, because in many companies your machine will be, this is my IP address of my machine, like where my database is there. Okay, this is my DB system, this is my database, only database. Okay, not the storage, not these data files. Okay, but in case of be on a safer side for like because data is very important. If the company loses data, that means everything is gone. Okay, they will mount U01, which is my data files storage area. Data files. Now this is mounted to my database. mounted. Now this will have its IP address. Now, if your memory gets full, then you can ask that you want to add more storage. They will add one more storage area, one more hard disk, and mount it back to this one. Now again, it will mount it. But while communicating from database to storage area or where the database resides, it have to use network bandwidth. And network bandwidth, again, it have to invoke the local processes on the OS side, take the network. With the help of network bandwidth, it will go right to the database file and again read from it. If it every time if make any kind of changes, if they have to go and write to database files and everything, that means all the memory which you've allocated for database will be completely used for perform this kind of action. So when other things will be done, like the performance tuning, indexing, recreating database files, select querying other database files, so that too takes a huge number of memory and RAM. So in that case, Oracle is designed in such a way that all the changes made to your database are not directly written to database file. Initially, they will be written in data logs file or database dirty buffer cache. So after a threshold is full, in that case, they will wipe off the memory from the dirty buffer cache or data logs, and then it will be returned back to your database files. Over here, you need to understand two things, to background process, which is very important background process, that is DBWR, WR, and it writes to data file. It writes to Dido logs. DBWR will never write anything to Dido logs. Sorry, this is LGWR. LGWR. And LGWR will never write directly to database files. Okay. Now you got the point. It's important question, like maybe in interview questions they ask you, can DBWR directly write to data log files or not, and will LGWR write to data files or not? So this will never do that. DBWR will never write to data logs file because it is not access to that. DBWR invokes data, it's a process which gets invoked, okay, when a checkpoint is occurred or anything like that, and then dirty buffer cache is written back to your database file. But DBWR can be invoked and it writes to database files, and LGWR writes to log groups. So by default, your data, when you install database, you will get data files, reader logs, control files. So this is the actually the heart of the system. If you don't have a reader logs, you can't start your database. The way database files, reader log files, they are very important thing. And archive logs, this is optional unless you don't put your database in archive mode. Archive logs won't be generated, but this is something when you start database, by default, it's there. Algebra will be invoked in following scenarios. Just a moment. Algebra is invoked whenever 1/3 of the redo log buffer is filled up, whenever the log data writes out 3 seconds, whenever 1 MB of the redo log buffer is filled. This means there is no sense in making redo log buffer more than 3 MB. Shutting down database, when you perform a shutdown database, all the redo logs buffer will be written to redo log groups. Whenever checkpoint occurs, when a transaction is completed, either committed or rolled back, then the Oracle calls the LGWR and synchronizes the log buffer to reader log files, and then only passes on the acknowledgement back to the user. This means the transaction is not guaranteed, although we set commit, unless we receive the acknowledgement. When a transaction is committed, a system change number is generated and tagged to it. Log writer puts a commit record in the redo log buffer and writes it to disk immediately along with the transaction redo entries. Changes to actual data blocks are deferred until a convenient time. Fast commit mechanism. When DBWR signals Similar to the writing of video records to disk, all records associated with changes in the block buffer must be written to disk first. The write ahead protocol. While writing dirty buffers, if the EDBW1 process finds that some redo information has been written, it signals the LWR to write information and waits until the control is written. Now you got about the LGWR and DBWR. Now see what is checkpoint. Checkpoint is a background process that triggers the checkpoint event to synchronize all database files with the checkpoint information. It ensures database data consistency and fast database recovery in case of recovery. When the checkpoint occurs, it will invoke the DBWN and update the SCN block to all database data files and the control files with the current SCN. This is done by LGWR. This SCN is called checkpoint SCN, checkpoint SCN. Checkpoint event occurs in the following condition: whenever database buffer cache filled up, whenever timeout 3 seconds for until ending, 1 second from 11G onwards, lock switched. Basically, it is something like SCN is something to mark your database that now it is to mark your database. Now go and clean your database buffer cache. All the changes which you have made to your database, which was residing in a buffer memory, now has to be written back to your database files. And once the changes have been written to database files, it also have to mark the SCN number in a control file. So next time, whenever you start a database after crash recovery, first thing is gonna go to the control file and check the SCN number. That SCN number in the control file and the SCN marked with the database files needs to be completely same. This is the job of CKPT. Can you see this one? It says checkpoint is a background process that triggers a checkpoint event to synchronize all database files with the checkpoint information. It ensures data consent faster recovery. When the checkpoint, it will invoke the DBWN and update the SCN block to all database files. It will update SCN block database files and the control file. So this makes, because it like unless you don't have a same record on two files, how would you maintain that both database file and the database file and the control file are properly in sync with each other? So we can perform this manually as well with the help of these commands. But whenever manual log switch is done, alter system switch log file, manual checkpoint, alter system checkpoint. So sometimes this thing is done in short. Like the example, suppose I want to take a backup of my database at 12 p.m. With the help of RMan. In that case, exactly at 12 p.m., I'm gonna perform these things: log system, alter system, switch log file, and with the help of this, whatever changes was done to the database, and whatever information, whatever data was residing in database buffer cache will be returned to my database files, and all the changes, all the SCN number will be marked to my database files, also the control files. So at that time, in time data will be marked to my control files. So if I take a backup of my system at the same time, it will make sure data will be inconsistent. Let me help you with what is checkpoint. In sometime you will face this thing if the developer of the functional team will tell us ask you to make a backup of a database from the production environment at specific time. In that case, this is my database. Okay, this is my database. Now there's a request: backup database till 9 a.m. Okay, this is like before the next day. You want to take a backup. That's a request. As you know, changes made database buffer cache. Okay, this have some changes. Exactly at new important was done. Exactly at 11:15, new important transaction was done. So this changes, you have no idea whether this, because you cannot see any changes made to, you cannot see anything in the database buffer cache, neither you can see any changes made in the database time. So you have no idea, because whenever now the changes made, like suppose somebody have done an update query for a table, which is in finance table, update query, update query, update table was executed. Now you perform the committed also. But as I said, commit doesn't mean it's gonna write the changes to database files. Okay. Because again, now somebody have done that. But now you have no idea whether the changes which you have done is make the changes have been reflected in control files or not. Data files. You have no idea, because database buffer is invoked when the its own threshold is completed or full, or else SCN is marked. When is SCN marked? You can either check when the checkpoint is marked, either whenever database buffer is filled up, but you have no idea whether the DB buffer cache is full or not, because you cannot see that thing.
Mm-hmm.
And you need to take a backup till 11:59 a.m. and that's important, and somebody have done some kind of update or DML perform on the database site at exactly at 11:50. Now you will be taking backup of database files, not database buffer cache. It's a memory of your database. It's a memory. Memory means RAM. It's a RAM buffer cache, but you will be taking backup of database files. This is the important files which have objects. So whenever database buffer cache is filled up, you have no idea whether it's filled up or not, or log switch have occurred or not. So in that case, what you will do exactly at 11:59 a.m., you will log to your database. You will log into your database and perform alter switch log file. This will manually ask the database buffer cache to wipe out the dirty buffers and write the changes made to your database files. So all the transaction which was done at L50 will be committed back to your database files, and also those changes will be SCN number will be marked, new SCN number will be created, and it will be marked in control file. This gives you consistency of database, because you need in time recovery. In time, you need the database exactly at this time. You want to recover database in other, you might want to clone this database in other environment, but also you have to make sure that the recent changes which was done on the database side is also captured. So in that case, you will perform this action manually. Only and only if something comes like this, like you want to have a database backup exactly at specific time in time or something. Not that before that, because you cannot do this thing manually every time. Now let's go to system small. The database is crashed, power failure. Next time when you start the database, small observe the last time the database was not shut down gracefully. Hence, it requires some recovery, which is known as instant crash recovery. When performing the crash recovery before database is completely open, if it finds any transactions committed but not found in the database file, will now be applied from the redo log files to database files. Now you understand that why all the transactions are not committed to database file. If it finds any transaction committed but not found in database file, it will. This is the reason I said it. All the changes made that are not directly written to database file, because it requires IO. It will be applied from the redo files to database file. So this scenario is valid over here. that. Yeah, database got recovered. It got crashed. You want to recover. How will recover? With the help of reader log files. Pseudo log files records all the changes made to your database. Okay, all the changes made together. So in this moment, if it gets crashed and it doesn't find the recent data from your database data files, because there might be changes in control file and the database file, so it's gonna go to the data log file and it will see whether it have recorded the changes made out to log files or not. If yes, then it will apply that changes to a database file directly. If SMON observes some uncommit transaction that has already updated a table in a data file, it is going to be treated as a doubt transaction and will be rolled back with the help of before image copy available in the rollback segments. SMON also clears up temporary segments that are no longer in use. It also cool space contiguous free extent in dictionary managed table spaces that have PC increase set to non-zero value. In rack environment, the S1 process is of one instance can perform instant recovery for other instances that have been failed. SMON wakes up about every 5 seconds to perform housekeeping activities. Housekeeping activities like recovery, other things. Okay. So we'll understand SMON later again because this is very important thing, SMON and PMON things. PMON. If a client has an open transaction which is no longer active, client session is closed, then PMON comes into picture and the transaction becomes in doubt transaction will be rolled back. PMON is responsible for performing recovery if a user process fail. It will roll back uncommitted transaction if the old session logged and gracefully will be unlocked by PMON. PMON is responsible for cleaning up the database buffer cache and freeing resources that were allocated to a process. If any user connect to database and suddenly his session gets disconnected, so PMON will come into the picture and it will see what kind of action the user was performing. If it was performing an update table and it was not committed by the user, it will roll back all the doubt transactions and clear that process to free up the memory for the other users. That's the job of the PMON. PMON also register information about the instance, dispatcher process, the Oracle network listener. PMON also check the dispatcher and server process and restart them if they have failed since Oracle launch. LG, listener registration process taking a time of listener process operations. PMON wakes up every 3 seconds to perform housekeeping activities. Recover, maximum 1G, RECO. This process is intended for recovery in distributed databases. The distributed transaction recovery process finds pending distributed transaction and resolves them. All in doubt transactions are recovered by this process in the distributed database setup. The RECO will connect to remote database to resolve pending transactions. Pending distributed transactions are two-phase commit transactions involving multiple databases. The database that the transaction started is normally the coordinator. It will send requests to other database involved in two-phase commit if they are not ready to commit. If a negative request is received from one of the other side, then the entire transaction will be rolled back. Otherwise, the distributed transaction will be committed on all sides. However, there is a chance that an error, not related or otherwise cause to two-phase commit transaction to be left in the pending state. We will understand this thing during the practical, this recovery process. Let's go to shutdown database. What happened with the shutdown? That total, when you shut down, when you just hit shutdown, normal shutdown, the normal shutdown clause of the SQL Plus shutdown is optional because this is default net shutdown method. If the option is committed, the shutdown operation process according to the stop option stored in the Oracle restart configuration for the database. The default option is immediate. Normal shutdown proceeds with the following condition. No new connections are allowed after the shipment issued. Before database is shut down, the database wait for all the current connected users to disconnect from the database. The next startup of the database will not require any instant recovery process. Why? Because right now you have done normal shutdown. So right now all the recovery, all the dirty buffer writing to database files is committed. Checkpoint will occur. It will mark the new checkpoint to database header files and also in the control files. So the next time when you start a database, no recovery will be performed after your database is restarted next time. All the recovery will be performed right now. Shutdown with immediate mode. Use immediate database shutdown only in the following situation: to initiate an automated and unattended backup when a power shutdown is going to occur soon. When the database or one of the application is functioning irregularly and you cannot contact user to ask them to log off, they are unable to log off. To shut down database immediately, use one of the following thing. Shutdown immediate, this is the command. Immediate database shutdown process with the following conditions. No new connections are allowed or new transaction allowed to be started after the statement is issued. Any uncommitted transaction are rolled back. If long uncommitted transaction exists, this method of shutdown might not complete quickly, despite its name. This means that somebody is performing any kind of transaction, that means it's going to wait for the user to perform all the transaction. Okay, until those transactions are not completed, this won't shut down the database that period of time. Oracle database does not wait for user currently connected to database to disconnect. The database implicitly roll back active transaction and disconnect all connected users. The next startup of the database will not require instant recovery process, because all the recovery which database require will be performed before database goes down. Shutting down with the transactional mode. Shut down transaction. Transactions database shutdown process with the following conditions. No new connections are allowed, nor new transaction will be started after the statement is issued. After all transactions have completed, any client still connected to the database is disconnected. At this point, the instant shutdown just as it would have when a shutdown immediate statement submitted. In this case, transactional means it is going to wait for all the transactions, current connected sessions to complete its transactions. Unless all the transaction is not completed, it won't shut down. So probably this method of shutdown will take quite a long time. Imagine somebody is about to update a huge million number of records, so it's going to wait for the user to perform all the transactions. Shutting abort. When you can shut down the database immediately with the aborting database instance. If possible, perform this type of shutdown only in the following situation. The database or one of the application is functioning irregularly and none of the other types of shutdown works. You need to shut down database intensely. For example, if you know a power shutdown is going to occur in 1 minute, you experience problem when starting a database instance. When you must do a database shutdown by aborting transaction and user connections. One of the following command. This is the command, and what really happens when you perform the shut abort. No new connection allowed. Not new transaction will be allowed to be started after the current statement is issued. Current as client SQL statement being processed by Oracle database are immediately terminated. Uncommitted transactions are not rolled back. Oracle database does not wait for user currently connected to the database to disconnect. The database implicitly disconnect all connected users. The next startup of the database will require automatic instant recovery. So next time when we'll start database after the shut abort, the smon will be invoked. This smon. If the database is crashed for failure next time when we start database, smon observe the last time database was not shut down gracefully. Hence, it requires some recovery, which is known as instant recovery. So in case of shut abort, your smon will be called immediately when you start a database next time after the shut abort.